Within these Army commands are developed the commodities instrumental in the defense of our country. Increased demands for higher performance and greater reliability have focused attention on the effectiveness of manufacturing inspection and quality control. Many plants are involved in the manufacturing and production of Army materiel. In the past, it was the practice of the government inspector to determine by actual physical inspection if the contractor's product met specified requirements. Since the inception of modern-day manufacturing operations and their continued evolution toward greater intricacy and acceleration, the inspector is continuously overtowered by products to be examined, resulting in delays, high costs, and the need for additional government inspectors to meet production schedules. Therefore, the need for a new method of inspection is essential. Such a method is evaluation, wherein a government survey is made of the contractor's facility by a government team. When a government inspector is in residence at a plant, the evaluation team first discusses the proposed survey with him. Contractors are given the responsibility for maintaining production quality. Thus, it remains for government to evaluate the contractor's quality control system. The first step in evaluation is a review of the contractor's administrative controls. Checklists are provided in order that the government inspector may apply a standard method for evaluating contractors' quality control systems. The contractor must have a detailed written statement outlining overall inspection policy. And through organizational delineation show lines of authority as well as number and types of personnel. The survey then extends into specific areas of the contractor's operations. Quality control must begin with the acceptance of incoming materials that go into the manufacturer's product. When the quality level is known to be high, the supplier's notarized report of compliance with previously established limits of acceptability may be used. Parts that require receiving inspection should be tagged to show serial number and inspection status. Furthermore, the contractor's system should provide for the separation and identification of uninspected and rejected parts. The evaluation team determines that the contractor has proper facilities and equipment for performing specified tests, such as this magnetic analysis comparison test for hardness. A torque comparison test for oil seals. A durometer test for qualifying rubber O-rings. A fast compression test for small coil springs, or any number of others. The important requirement in each case is that test procedures and standards are applied and records maintained. Typical of laboratory examinations that may be specified is the tensile test, the procedure most often used to evaluate the mechanical properties of a material. Or the Sharpie impact test, which accurately determines ductility and impact strength of a metal specimen by a single blow of the pendulum. Or the Rockwell hardness test, with its surface penetration by application of minor and major loads. Radiographic inspection may be required to determine subsurface defects or other structural discontinuities. Regardless of the type of test, quality data generated by the contractor must be used to a maximum. In order to evaluate and verify the contractor's machining inspection, the survey team must determine that individuals charged with the responsibility of quality examination are thoroughly trained. In addition, reference material to guide the inspector and keep current his procedures must be readily at hand. The carefully written statement of duties promotes complete understanding of the inspection job. Also, the team should determine that the operation is performed as described. And that step-by-step instructions are conspicuously posted. The contractor must maintain records of the inspection performed as objective evidence that the system continues effective and uncurtailed. He should maintain a written procedure setting forth instructions and policy necessary for close control of drawings. The procedure should provide for the distribution of latest applicable drawings in an orderly manner to assure availability at the time and place of inspection, as well as removal of obsolete information from production. Production jigs and fixtures used in inspection must be calibrated at established intervals. And the flow of components controlled to assure that only acceptable parts go into the final product. When material is found to deviate from requirements, it must be identified and withheld from use until deviation approval is secured. The government shall take immediate action to eliminate unsatisfactory conditions in the contractor's system. Deficiencies detected in the survey, such as the forcing of a gauge, are entered on a deficiency report with recommendation for prompt corrective action by the contractor. Flame cutting and welding are used extensively in the fabrication of Army materiel. Prior to conducting the survey of a special process, such as welding or welding inspection, the government inspectors should first consult with a specialist for briefing in order to approach a particular manufacturing operation with intelligent evaluation technique. Aside from detailed written procedures, specifications may also require qualification of the welding operation, equipment, and the welder himself. Plating, another special process, requires the surface to be properly cleaned and prepared with care if the coating is to possess the necessary characteristics of good adherence, uniformity, and continuity. In addition, plating requires close control of solution, temperature, and time cycles. In heat treating, a third example of a special process, close adherence to predetermined practices is required to achieve desired product characteristics. A significant control in this area is that of quenching, with particular attention being paid to cooling medium and immersion method. Temperature-controlled devices that regulate the time and temperature cycles of the process require periodic inspection. In this heat-treating machine, the piece descends vertically, is heated by induction, and quenches in a continuous operation. Thus, one of many automatic processes in which machines may control quality. However, controls too must be subjected to checks, and while precision machines may materially reduce inspection loads, the treated part receives a final test for hardness. In a complex assembly operation, an instruction sheet should show the prescribed sequence of operation. All parts coming into assembly must be controlled as to type and should be skillfully handled in order to ensure the intended function. In addition to the use of proper facilities and equipment for performing assembly operations, installation techniques are carefully applied, even to the use of impact tools. The nature of the item, its function, and interchangeability influence the amount, degree, and methods of quality control. Although individual units, components, and sub-assemblies have been previously inspected, complete assembly operations often must be determined by additional verification, such as achieved by this dynamometer. Here, a transmission undergoes a functional test on a dynamometer as required by specification. The controlled issue of inspection equipment is a necessary measure for maintaining product uniformity and interchangeability. As in other special processes, it is necessary that a government specialist aid the inspection team in evaluating the contractor's tool, gauge, and measuring equipment. Measuring and testing equipment used in production runs must be initially inspected and approved, and then re-inspected with masters at established periods in order to assure continuous accuracy. The micrometer and similar measuring instruments likewise require periodic re-inspection and calibration against standards for maintaining precision. Single-purpose inspection devices, such as this gear-checking machine, are highly desirable for minimizing error by readily indicating the acceptability or unacceptability of production parts. The contractor's record of gauge surveillance and maintenance should be scrutinized by the evaluating inspector, including dates that recheck or repair are anticipated. When deemed necessary because of field reports or to verify quality, items already passed by the contractor may be re-inspected by government inspectors and the results compared. The preparation of product for packaging must include a survey for the correct application of specified cleaning and drying procedures. Where dip coatings or other preservatives are employed, the barrier characteristics demand careful consideration. An improper coating could accelerate and conceal deterioration. Packaging is evaluated for method and for conformance of cartons or other containers to assure approved design, proper construction, the support of inserted items, and adequate transport protection. In any checklist for packaging, inspection should include the correct application of closing devices. Likewise, these controls extend to case packing or the enclosing of the unit packages into a transportable package. Proper marking for shipment must be assured. Incorrect nomenclature or code indicating package contents can have serious consequences, while misrouted material may actually jeopardize or delay an entire military operation. Surveillance over the transportation and storage of parts must be exercised carefully. Thus, every phase of packaging inspection must assure delivery of acceptable product. At the close of the evaluation survey, all information that was recorded on the evaluation checklists is used by the evaluator to determine if the contractor's system is acceptable or not acceptable. Although evaluation is by no means the only facet of the Department of Defense Quality Assurance Program, it is a very important one, which must be properly coordinated with other activities at a high management level in order to produce maximum benefits. Determination of conformance of the product to contract requirements shall be made on the basis of objective evidence of quality and quantity. It is essential that the government inspector shall make optimum use of quality data generated by contractors in determining the acceptability of supplies.